Top 5. All right. I'll take that.
Out of 4.
Cool. So I'm going to be talking about graph analysis of Russian Twitter trolls. So my name's Will. I'm a developer at Neo4j. How many people are familiar with Neo4j? Okay, awesome. So I work on our developer relations team. I focus on building out integrations so that you can use Neo4j with your favorite web development framework, move data around. Currently, I'm building out our GraphQL integration, which has been an interesting project. But I also spend a lot of time with users trying to help them be successful with graphs, do workshops, and things like that. And I also run what we call the Neo4j Data Journalism Accelerator program. And the goal of this program is for us to devote some technical resources to help data journalists use Neo4j to make sense of interesting data sets. So my talk today is largely going to be a case study in one of these projects. And this journalism program fits well with our mission statement, which is simply to help the world make sense of data. So for this project, we worked with a data team at NBC News that was interested in looking at this Russian Twitter troll data. And so we'll dig into this in a bit of detail. And largely, I want to just talk about some of the ways that we can make sense and find stories, find insights in a data set like this using graph databases. So first of all, just for those that are not familiar with graphs and graph databases, just a quick overview. So what's a graph database? So when I say graph, I'm not necessarily talking about data visualization like charts. We're talking about the data structure graph. So objects are the entities, relationships connect them. Okay, so that must mean that a graph database is something that stores graphs. Okay, that's part of it. Let's get a bit more nuance on that. And since we're talking about Twitter data, I think a tweet is the best way to get that across. So what is Neo4j in 140 characters? Well, Neo4j is open source software that stores and queries data as nodes and relationships using the Cypher query language with index-free adjacency. Okay, so there's a lot going on there. So let's dive into that a little bit. So first of all, open source. Neo4j is open source. All the code is on GitHub. We provide distributions that you can download on desktop, deploy using Docker in the cloud, and so on. Really easy to get started. Stores and queries data. So Neo4j is primarily a database focused on data durability. When you commit a transaction, it's guaranteed to be safe. We allow you to query your data using what's called the property graph data model. Nodes, we said, are the objects in the graph. Relationships connect them. This data model that we're seeing here actually comes from the Paradise papers, another data journalism investigation. The data journalists for this project used Neo4j to make sense of the connections between people and offshore corporations that they may have registered to find insights in that data. So the next piece in our tweet here is we query data as nodes and relationships using the Cypher query language. How many people have written a Cypher query before? Okay, cool. So Cypher is a query language for graphs, like SQL, but for graphs. Cypher is very much about pattern matching. So you can see here we're using this sort of ASCII art representation of a graph to define a pattern that we want to match on in the graph. So here we're looking for addresses that contain the string Texas. We're traversing incoming relationships to these addresses to find the officers, so who are the people with an address in Texas. Then we're traversing out to find the legal entities, the offshore corporations that those people are connected to. And if we were to run this query in Neo4j browser, which is a query workbench for Neo4j that lets us run Cypher queries and visualize the results, we would see this. So this is the graph of everyone with an address in Texas that shows up connected to an offshore corporation in the Paradise Papers leak. And this allows us to explore the data visually. Just looking at this, we can see this big cluster right here. Someone's very connected to lots of offshore corporations, so that's something that might be interesting to dig into. But we're not necessarily always interested in getting graph visualization or graph results. Sometimes the answer to our question after traversing the graph is tabular data. Let's say maybe we want to run an aggregation. So here's a slightly different query. This says, for everyone with an address in Texas that's connected to an offshore corporation, group by jurisdiction and give me a count. So what are the most popular offshore jurisdictions for people from Texas? Well, number 1 is the Cook Islands, followed by British Virgin Islands, Bermuda, and so on. So the point I want to get across here is just that we can work with both graph results and tabular results. We have in Cypher some of the same semantics that you would expect from SQL, things like group bys, aggregations, and so on. So Cypher started with Neo4j, but since been open sourced as part of the openCypher project. And the goal there is to make Cypher available for lots of different graph projects, graph databases, data processing frameworks, visualization tools, and so on. And there are some projects implementing Cypher now. An example of that is Cypher for Apache Spark. So you can define a Spark job using Cypher, which is pretty cool for analytic use cases. Okay, and the final bit in our tweet here is that we can query data using Cypher with index-free adjacency. So index-free adjacency is a very important performance characteristic with graph databases and Neo4j. Basically, what this means is that we can traverse from one node to any other node that this is connected to by a relationship without hitting an index. So what this means is that a local graph traversal is then a constant time operation. It's not dependent on the overall size of the graph, just the piece that I'm traversing. So this allows us to scale our queries to very, very large data sets. Yeah, we'll do questions at the end, yeah. Okay, so we like to say that graphs are everywhere. Oftentimes you're thinking of, okay, well, what sort of use cases make sense for graphs and Neo4j? Here are some of the most common use cases, but really we see people using graphs and Neo4j for almost anything. Real-time recommendations, fraud detection, I think are some of the most common, but really we have people building knowledge graphs, working with IoT data, and so on. So for me, and hopefully once you start thinking in graphs, you'll sort of start to see graph problems in lots of different domains and lots of different data sets that you're working with. Okay, so that's a brief overview of graphs and Neo4j. Let's get back to talking about our Russian Twitter troll data. So this was published in a story that NBC News wrote up. We did some of the data analysis with them to try to help make sense of this data. So first of all, what data are we talking about? What are these Russian trolls? Well, as part of the House intelligence investigation into how Russia may have influenced the 2016 presidential election, Twitter released about 3,000 screen names of accounts that they believe were tied to this company called the Internet Research Agency in Russia. And this company is known to operate Twitter bots and have a staff of people that go on social media and sort of spread fake news and basically just act as trolls on social media. So Twitter released these screen names and said, oh, these are Russian troll accounts, and then immediately suspended those accounts. Well, that deleted all of those tweets from twitter.com, made them no longer accessible through the Twitter API. So journalists were largely asking, okay, well, what were these accounts tweeting about? Like, this is an interesting story. where's this data? So when we were starting to talk to the NBC folks, we spent some time trying to get this data. The first thing we did was look at Internet Archive. So Internet Archive caches websites. They have an API. It's really easy to construct what would be the user profile page for a user, send that to the Wayback API, and we get the most recent cache if it exists for that user's profile page. So we did that. Then it's just a matter of scraping the HTML for the tweet data. And if anyone's worked with data journalists, you get really good at writing web scrapers, because that's where a lot of the data for these stories come from. Not often in nice forms to work with. And we had to write several different versions of this scraper because the HTML structure changes over time, and these were caches at a certain point in time. So we did that, and we stored the data we extracted in JSON that roughly approximated what you would get from the Twitter API. And the nice thing about that is we can pass that JSON as a parameter to a Cypher query. And then this Cypher query just defines, again, using this sort of ASCII art notation, how we want to create data in the graph. So this was our import process for that into a graph model. So this is the graph model that we use to represent the tweet data. So you can see we're modeling users as a node, tweet as a node. So a user posts a tweet. The tweet has maybe a hashtag. Maybe it was posted using some software. It has maybe a URL that the tweet is embedding. And with this got us some of the data. I think we found maybe just under 2,000 tweets for maybe 150 of these 3,000 Twitter trolls that were on the list. So that was just a small fraction. Meanwhile, it turns out that there were lots of people passively collecting data around the election from the Twitter API and saving that for a rainy day. So the NBC News folks got some anonymous data given to them from people that were collecting this. We aggregated all of that together into our graph model, and we ended up with over 300,000 tweets posted by a total of 41,000 users, and about 450 of those were Russian trolls from this list of 3,000. So the 41,000 users, these are sort of civilians or bystanders who may have interacted with these Russian trolls on social media. They were either retweeted by them or mentioned in a tweet. Okay, so it's interesting to start to look at these users now that we have some of their information. So what does the typical Russian Twitter troll look like? Well, there are roughly 3 categories of these types of accounts. One that is sort of made to look like your typical American citizen. So here's an example. Here's Leroy Loves USA. And this is his actual profile image. So this is maybe a Russian's version of the quintessential American conservative, I guess. The other class of these accounts were made to look like a typical local news publication. So Cleveland Online, giving you breaking news, weather, traffic information from Cleveland via Russia. And the third category were actually accounts made to look like local political party accounts. So 10 GOP, this is actually one of the more prominent accounts, was intended to look like it was affiliated with the Tennessee Republican Party. But of course, these are all Russian troll accounts being operated by people in St. Petersburg. So here's an example of one of these tweets from our friend Leroy. So Leroy posted this tweet. Here, the Cypher query is basically just looking for tweets that Leroy's posted that use the hashtag Thanks Obama. And if we look at the cached version of this tweet, it embeds some images. And here, Leroy is taking credit for hanging a banner on the Arlington Bridge in DC that says something about Obama being a murderer and glad he's gone. And what's interesting here is that this actually happened. Someone actually did hang this banner on a bridge. So you're seeing these Russian accounts try to latch on to events that are actually occurring and trying to amplify that message. So one of the things the NBC folks were interested in is, again, looking at sort of how real world events are tied to what's going on in Russian Twitter land. And we can see that just the volume of tweets posted by these Russian trolls spikes significantly when there are things like terrorism attacks going on, or during the debates, or when Trump wins the nomination. And again, this is largely about amplifying this message and just sort of trying to introduce chaos around these events that are going on. One of the other interesting things that the NBC folks wanted to look at was the use of hashtags. So hashtags, of course, were used by these Russian accounts to try to insert themselves into the conversation and try to gain visibility. But also, it's interesting to look at sort of how we saw the spread of hashtags that originated in these Russian accounts that then we saw regular people actually using these hashtags. And a great example is from the World of Hashtags user. That's a Russian troll. He was the first one to post the hashtag rejected debate topics around the debate, coming up with, okay, what are topics that basically anti-Clinton message. And then regular people started using this hashtag as well, posting their own. And there are actually several hundred bystanders, civilians, non-Russian trolls that actually ended up using this hashtag after this Russian troll account had sort of started it. So it was very interesting to look at sort of this spread of the hashtags and themes through social media that the troll accounts were able to begin. And we can look at some other sort of simple analyses. So here's looking at replies and who they were replying to. So as opposed to creating what we termed original content, so a tweet that's not a reply, instead sort of mentioning a user or replying to a tweet from another user to try to basically gain visibility in that user's timeline. The second one is kind of cut off there, but the top two are Donald Trump and Hillary Clinton were the most common accounts that these Russian trolls were mentioning, and then some other news publications, and then basically nothing. So they're basically focused on accounts with lots and lots of followers. So looking more into this breakdown of retweets, replies versus original content tweets, what's interesting is that the vast majority of the tweets that we were able to capture from these Russian accounts were simply retweets, retweets of other trolls and also just of regular users. And in this chart, you can see, so blue is retweets, the yellow is original, and then the red are replies. So you can see that some accounts were just retweeting, and actually very few were actually generating lots of original content. We can also look at the source of the tweet, so what Twitter app was used to post it. So the vast majority were done through the Twitter web clients, but there are also some scheduling apps like TweetDeck and that used as well. We can look at the domains of the links posted. Nothing really super interesting that pops out here, except that a lot of these are mainstream publications. So they're not necessarily posting lots of completely fake news story. Although using a link shortener, I think we could have sort of resolved some of these in a bit more detail. But this is sort of the first breakdown. If we look at the hour of the day, so this is tweet volume by hour of day in UTC time, and we see sort of a spike there when the trolls show up to work and start tweeting at 9 a.m. Moscow time. So that's interesting to see. And of course, a lot of these other tweets are scheduled using some of those social media tools that we saw as well. But I thought this was fun. Okay, so that's some basic analysis. Let's talk about some more complex tooling that we can use to try to make sense of this data. So natural language processing. So who's done some NLP stuff? Okay, yeah, so a few folks. So here's some common NLP tasks, things like entity extraction, sentiment analysis, summarization, word similarity, mapping to a concept hierarchy. And there are lots of really great open source tools for NLP. So when we want to do some NLP tasks, we don't have to reinvent the wheel here. We have a lot of tools to work with. Making the observation that most NLP tasks are about annotations. So annotating text. So how do we annotate a graph? So how do we annotate this tweet? Well, we do that by creating nodes and relationships. So if we run an entity extraction algorithm, we're going to create nodes for persons, organizations, locations, and then a relationship that says this tweet contains a mention about this organization. That allows us to query through this organization to see, okay, what are all of the tweets that mention some company or whatever, the Republican Party, whatever it is. So that's how we annotate the graph. Okay, so how do we use some of these great open source NLP tools with Neo4j? Well, Neo4j is very extensible. So we can basically push code to the database that extends Cypher and then call that code as a function from Cypher. These are called user-defined procedures. And the folks at GraphAware, which is one of our partner consulting companies, they've built this GraphAware NLP tooling as a Neo4j plugin that embeds some tools like Stanford Core NLP and ConceptNet that allow you to use some of these tools directly from Cypher. So we can just match on all the tweets, grab all the text, pass the text to this NLP.annotate procedure that will run entity extraction, sentiment analysis, part of speech tagging, and then create nodes and relationships to annotate the graph. So that's a really useful tool. Then once we've annotated the graph, then we can use Cypher to write some queries to try to make sense of this. So here's a query that says, show me all of the tweets posted by trolls that contain the entity Louisiana. So who's talking about Louisiana? And then we're looking for what hashtags are they using, what other entities are they talking about. And we can see that some of these tweets are talking about New Orleans. It's actually the vast majority of these ones here. We can see some of them are talking about Trump in Louisiana, and so on. There's a lot more we can do with NLP, sentiment analysis, and so on. But hopefully that gives you an idea of how to access some of those tasks. So next I want to talk a little bit about graph algorithms and how we can apply them to this data set. So one class of graph algorithms that we see used a lot are centrality algorithms. So centrality measures the importance of some node in the graph. And there are several different versions of centrality. One of those is PageRank. So this, of course, is the algorithm used at Google to rank web pages for search engine. So PageRank is this recursive algorithm where the importance of any node is determined by the importance and number of nodes that point to them. PageRank is useful for identifying sort of influence in a network typically. Another centrality measure is betweenness centrality. So betweenness centrality is simply the count of the number of shortest paths that go through a node in the network. And what we can see here, and this is an example shown by these red nodes, those are nodes with high betweenness centrality. And they often end up being sort of local bridges that end up connecting clusters of the graph. So oftentimes these are important pieces of the network that are responsible for transferring information from one cluster in the graph to another. And the third measure of centrality that I'm going to talk about is closeness centrality. So closeness centrality is simply the inverse of the distance from one node to all other nodes in the graph. And these nodes typically end up being highly connected within their own cluster, but not so much outside of the cluster. So these may be influential within their particular piece of the graph, but not so much beyond that. And there's another class of algorithms, community detection or clustering. These are different things, but similar enough that we can talk about them together. It's basically used to partition the graph. They do this by minimizing what's called modularity, which is the ratio of the relationships within a cluster to the number of relationships that go outside of the cluster. So these are iterative algorithms. Things like Louvain, Union Find, and Walk Trap are some implementations. Okay, so those are graph algorithms. How do I run them in Neo4j on this Russian Twitter troll data set? Well, I want to take a step back and talk about a project a few years ago that did something similar. So this was John Swain's project. He was a data scientist at Right Relevance, and he was collecting Twitter data around things like the climate debates and things leading up to Brexit. And he wanted to sort of look at if he could partition these Twitter accounts. He was looking specifically mostly at news accounts to see if are they pro-Brexit, are they pro-Remain or Leave, who are the influencers in this network. And he showed us this pipeline that he had built where he got data from the Twitter API, put it in a queue, dumped that into Mongo, imported that into Neo4j, got data out of Neo4j into R to run some graph algorithms, then exported that into MySQL so we could use Tableau for visualization, also dumped that to a GraphML file so he could use Gephi for graph visualization. And he was really proud of this, and it totally worked. But we took a look at this and thought, wow, that's a lot of moving pieces for your pipeline. There's a lot of complexity there. Is that really necessary? And so this was sort of the inspiration for our graph algorithm project at Neo4j. We thought, well, we can remove a bunch of these pieces. We don't need to pull the data into R or Spark. We can just run these algorithms in Neo4j. We have the extensibility built in there. So that was largely the inspiration, and the goal is to replace these pieces in a pipeline like this. So this inspired the Neo4j Analytics project, which is basically this idea of being able to run these graph algorithms in Neo4j using Cypher. So we have things like pathfinding algorithms, which we haven't really talked about, but we also can do community detection and centrality algorithms as part of this. How does this work? Well, we can call these algorithms from Cypher. So we just specify the type of node and the type of relationship that we want to run these algorithms on. And we can then write these values after they're computed back to the graph, so add properties to these nodes. And then that allows us to then operationalize the result of those using our Cypher queries. So after we run PageRank, we can then maybe in a recommendation algorithm say, okay, who's the most influential customer in my product purchase graph? Let's look at what they're buying to make recommendations, things like that. But we can also run these algorithms on a projection of the graph. So what does this mean? Well, inferred relationships are really, really important in graphs, and specifically when we're doing this type of analysis. If you were in Dave's talk previously, he talked about a bit of the power of inferred relationships in the graph. So here's an example. So we have a troll account who posted a tweet, and then another troll account retweeted this, and it's modeled as a new tweet that retweets the other user's tweet. And we sort of have this inferred relationship then between these two users, where we can say that this user amplified this user's message, right? Because he retweeted something that he had posted. So what we want to do is run our algorithms on this amplified graph that doesn't actually exist in our data set. We don't actually persist these relationships. Instead, we want to infer them from the graph. And we can do that just using Cypher. So we can pass in to our call to PageRank the Cypher query to generate this inferred graph. And that's actually what the algorithm is run on, which is really cool and really, really powerful. So the architecture for these graph algorithms are basically to load data in parallel from Neo4j into these efficient algorithms that are still operated within Neo4j to run these algorithms and then write the data back to our nodes in parallel. So it's meant to take advantage of multiple cores that we have available. Doing some initial rough performance comparisons for most of these. Neo4j is as fast or as faster than Spark on equivalent hardware, which is exciting. So that's good. And we've been able to run these on large data sets. So this is running PageRank on a 3 billion node, 18 billion relationship graph, and that works. That's great. Okay, so we've run some graph algorithms. How do we interpret those results? This is where graph visualization comes in. So graph visualization is really important for two things in graphs. One is for exploration. So when we saw those screenshots of Neo4j browser earlier, we saw how we could sort of use that tool to explore the graph, to see who's connected to who's tweeting about what hashtags, and so on. And the other aspect that's really useful for graph visualization is sort of roughly graph summarization, or sort of making sense of the total graph or a large piece of the graph. So here's an example. So we ran PageRank and a community detection algorithm on our Russian Twitter graph. This is on the amplified piece. So this is running PageRank on trolls that are retweeting or mentioning each other. And then in this visualization, we're binding node size to that node's PageRank, color to the graph partition that the node belongs to from our community detection algorithm, and relationship thickness is the weight or the number of times that that user amplified the other user's message. So we can look at this and we can quickly see there are roughly 3 partitions in the graph. And if we dig into that and start looking at the tweets, what we found is that this red group is largely tweeting about right-wing politics. The yellow group is largely tweeting about more left politics and tweeting a lot about Clinton. And this small purple group down here is tweeting about Black Lives Matter. So you can see how just running the algorithm, not knowing anything about the content of these tweets, is able to partition it in a way that we can then sort of interpret and dig into further. And remember the Tennessee GOP account earlier that we saw ends up being the most influential in the graph overall as defined by PageRank. So this is an example of how we can interpret our algorithms using graph visualization. By the way, that was generated using the simple library that I wrote called NeoViz, which bundles a library called Viz.js, which is useful for generating data visualizations for the web, and bundles the JavaScript driver for Neo4j. And the cool thing is you don't have to write any Cypher or translate the data. Basically, you just define some configuration and you say, I want to map the size of the node to some property, in this case page rank, in the graph, and I want to map the color to some property, and so on. And it generates the Cypher query necessary to fetch that data from Neo4j, translates it into the format for Viz.js, and allows me to embed it in my application. So something that I found useful to build for these sorts of visualizations. So there were some surprising takeaways. This was a really fun project to work on. I was really amazed to see that, trying to influence elections is just another 9-to-5 job that you go to the office and try to dig into social media as a troll. Really, the big challenge here was data availability. This I think is a really important data set that we can try to figure out what is going on in social media that largely is unavailable to journalists to make sense of. So that was an interesting challenge to work through as well. This is the first story that NBC News has published. There'll be more coming out soon. So I would encourage you to check that out. There's a lot in the story that I didn't really talk about. If you're interested in playing around with Neo4j, learning more about Neo4j, I would encourage you to check out Neo4j Sandbox. So this allows you to spin up Neo4j instances preloaded with data sets focused around certain use cases. There's one for generating personalized recommendations, looking at network and IT operations. The Paradise Papers data set is in there as well. So that's really fun to play around with. Also, we have a booth upstairs. I'll be there for the rest of the day, so feel free to come by and chat if you have any questions or want to dig in further. So that's all I have. I think it's almost lunchtime, but I will certainly be happy to take any questions that anyone has.